There are at least two ways to characterize a line in the 3D space. A line in the 3D space can be written as the intersection of two planes in the 3D space. And remember that a plane in the 3D space can be characterized by a linear equation. So a line in the 3D space can be characterized by a system of two linear equations. And also the plane equations are coming from a point on the plane and the vector perpendicular to the plane. So the line equations are coming from a point on the line and the two vectors perpendicular to the line. We can also characterize a line in the 3D space from a point and a direction. If the line passes through the point R0 and the line has a direction v, then the line can be characterized by a vector function here. Here it is a very special function. It has a one-dimensional input, but it has a three-dimensional output. R of a real number t here is equal to R0 plus t times v. Now the real problem is how can we translate one description into the other description? Suppose we are given a description of a line using a system of two linear equations. Then we try to solve this linear system and get at least 2 points from the equations. And we can compute the direction v from the difference between these 2 points. Now, suppose we are given a line in the form of a point and a direction. Then we can get 2 points from the vector function here. The 2 points are r of 0 and r of 1. So it is r0 and r0 plus v. And then we find two linear equations such that this point satisfies those linear equations. And in this way, we can translate it back into the linear system.